Today we're going to be talking about multiplying and dividing by 10, 100, and 1000. Okay, so what we're going to be doing is we're going to be using place value and patterns to multiply and divide by powers of 10. So this chapter unit we've been talking about place value is going to come into play and hopefully make dividing, multiplying by 10, 100, 1000 a lot simpler for you. So before we get started, we'll go ahead and throw up the problem of the day for you if you've been following along doing those. So here we go. Here's what it says. Illinois, Maine, Missouri, and Alabama were the 21st to 24th states to join the Union. Illinois and Alabama joined before Maine. Missouri was 24th. Alabama was not 21st. In which order did they join? So go ahead and pause here if you're trying to get that solved. And then we will go ahead and move along. Okay, so now that you maybe attempt the problem, maybe you can skip past it. We're going to go ahead and set the scene for what today's lesson is going to be looking like. So you know how to multiply whole numbers by 10, 100, and 1000, right? That's something that you've worked on before. But now we're going to apply that to decimals. So what I want you to do for a second is just stop and think about how you can kind of use a shortcut on multiplying whole numbers times 10, 100, and 1000. Okay, so when you do that, all you really have to do is add a zero for however many zeros are in the number that's multiplying. So, if I was multiplying 4 times 10, there's 1 0 in 10, so that's going to equal 40. I'm just going to take that 0 and add it to my other one, right? So that's how we multiply whole numbers. You've done that before. If I said 4 times 1000, then there's 1, 2, 3 zeros. We're going to add that on. I'm going to get 4,000. So we're going to use kind of the same type of looking for patterns. We're going to use that and apply that in decimals. So let's go ahead and get started. So here's the first problem we're going to take a look at to get started. Let's pretend that you want to make a bracelet. And to make a bracelet, you have to buy a bunch of beads, right? Each bead is going to cost you 3 cents. So I went ahead and wrote that on the board. So if you were to make a bracelet with 10 beads, how much would it cost in beads? After you figure out how much it's going to cost you to make a bracelet with 10 beads, I want you to figure out how much it's going to cost you to make a bracelet with 100 beads. I want you to go ahead and solve this on your own. So go ahead and pause the tape here in a second. But you can use any method you want. Just figure out how much it's going to cost for 3 cents a bead to make a bracelet with 10 beads and to make a bracelet with 100 beads. So go ahead and do that now. So let's break down this problem. If you have 1 bead, that's going to cost you 3 cents. Now, if we want to look at how much 10 beads is, well, what's that going to look like? We're going to have to take 10 times 3 cents, and that's going to equal 30 cents. I'm going to move you over a little bit because what we're going to do is we're going to keep extending this. And 30 cents can also be written as 30 cents, right? If we're using the dollars and cents notation. Okay? So, let's go ahead and look at 100 beads. Well, how are we going to figure out 100 beads? With 100 beads, we take 100 times that same 3 cents, and that's going to equal 300 cents. But you're not going to go to the store and they're going to say, all right, you owe me 300 cents. How are they going to write that? They're going to write that in dollars and cents notation again. And so you're going to end up owing them $3. So go ahead and stop and pause and look and see if we can find any patterns. If you could find a pattern, let's see if I can make it a little bit more simple for you. I'm going to go ahead and erase our equations. But I'm going to keep our dollar amounts. So 1 bead was equal to 3 cents. And I'm going to write it in our dollars and cents notation. So 1B is equal to 3 cents. If we take 10 beads, we're going to have to pay 30 cents. If we have 100 beads, we're paying the $3. So now let's take a look and see if you see any pattern. So 1 bead is 3 cents, 10 beads is 30 cents, and 100 beads is $3. So do you see a pattern here? Look at this. I see that there's a pattern of however many, just like when we multiplied, we used the zeros in the tens, 100s, or 1000s. We used those zeros to count how many zeros we're adding into the product. This time what we're doing is we're going to look and see, okay, there's 1 0 in 10, and that's how many times we're going to move the decimal point to the right in our product. So we started out with 1 bead being 3 cents. Then we wanted to multiply. Okay, now I have 10 beads, each costing 3 cents. So when we're multiplying a decimal times 10, 100, 1,000, all we have to do is move that decimal to the right, however many zeros we have. So if I'm multiplying times 10, if I move the decimal one place to the right, then I'm going to end up with this answer of 0.3. If I'm multiplying my same 3 cents times 100, well, how many zeros are 100? 1, 2. So with my starting number, how many times am I going to move the decimal place to the right? Well, the 2. So it's going to start where it originally started. Then I'm going to go 2 places to the right. So we're going to go 1, 2. So my decimal point is going to be right after the 3 when we're looking at it times 100. And if you look, that's what our answer was. The decimal point ends up being right after the 3. So let's see if this pattern holds true. What if I wanted to do 1,000 beads? Well, if the pattern holds true, then I just need to move my decimal point one more place. So let's not mess with all the junk that we have going up here. We're going to go ahead and start with our 3 cents. And since I have 1, 2, 3 zeros in 1,000, I'm going to move my decimal point 3 places to the right. So we're going to go 1, 2, 3. And then I need to place my decimal point. But I have a little space here. So what's going to hold the space? Well, a placeholder. It's going to be a 0. So now when we write it, we have 3, 0, and then a decimal point. And since we're talking about money, we've always got those extra 2 place values right at the end after decimal for our cents. So we're going to go 0, 0. Do those zeros mean anything? Are they worth anything? No, but they're telling us we have 0 cents. Well, hopefully you have some sense. You get what I'm saying. So 1 bead is 3 cents. I'm going to erase these little squigglies to not throw us off a little bit. So 1 bead is 3 cents. 10 beads is 30 cents. 100 beads is 3 cents. And 1,000 beads is $30. That's an expensive bracelet. That's a big bracelet. But you get the picture. So if we look, we can see that our decimal point is traveling 1 place to the right each time. So that's what we're getting into today. Let's look at a few more problems. Before we jump into our guided practice, let's do one more example just to make sure we have everything cleared up. So if I were to write the number 0.12 on the board, or if you remember when we were talking about our place values 2 lessons ago, this is the tenths and this is hundredths, so this is 12 hundredths. If I were to write 12 hundredths on the board, how could we get this looking if we did it times 10 times 100 and times 1,000? This time when I do it, I'm going to keep the decimal points lined up so we can kind of get a visual of that. So 12 hundredths times 10. How many zeros are in 10? 1. So how many times are we going to move the decimal place to the right? We're going to move it once. So our answer is going to be 1.2. And the next time we're taking 12 hundredths times 100. How many zeros? Well, we have 2 zeros, so we're going to move it 2 places to the right. 1, 2. So our decimal this time is after the 12. Now we're going to take 1200 times 1,000, and we have 3 zeros in 1,000. So that means we're going to move the decimal point 3 times to the right. 1, 2, 3. So again, since I have that extra space, I'm just going to throw in a 0 for it. So our decimal will technically be here at the end. What I did, I just went ahead and left off the extra zeros because I could throw in some zeros if we needed to. But they're not needed. Once our number, it's a whole number that we're left with, so we don't need any decimal points or zeros at the end of it to show that. So what we're doing is we started with 0.12, and then as we get bigger and bigger, the number starts to grow. So that's what we're getting into. Let's check out a few practice problems together. Okay, so now let's go ahead and jump into your guided practice section, and let's see if we can work through a few problems. So for number 1, this one's going to be really kind of basic in what we just did in our practice, or in our introduction to the PBIL section, right? So we have 3.98, so 3 98 hundredths, and we're going to multiply that times 10. Well, again, we're just going to use the same thing that we've been practicing. There's 1 0 in 10, and we're multiplying, so our decimal goes one place to the right. So our answer is going to be 39 8/10. So we went 1 to the right because we had 1 0 and 10. Problem 2 is going to cause us to think outside the box a little bit. 95 2/10 times what is going to get us to 9,520. So now we have to think a little bit and realize that it's going to be either 10, 100, or 1,000. And if we look at our answer, we can fill one of those in just looking at how many times the place value changes by moving the decimal. So if I look and I start at 95.2, how many times am I going to have to move the decimal to the right to get to 9,520? Well, let's look. 95.2, we move it 1, 2 times. If we start in here, we go 1, 2, and we're there. So we move the decimal place 2 times to the right. So we multiply 95.2 times 100. And just to remember our lessons a few back, if we're writing that exponential value, that's also 10 to the power of 2. Because remember, to the power means this is how many times we multiply the base times itself. 10 times 10 is 100. So it can also be 10 to the power of 2. Let's look at number 3. This one's going to add another curveball for us. So now we have 1,342.9, but our symbol now is divided by a number equals 1.3429. So we haven't been talking about division, we've been talking about multiplication. But one really cool thing is that we know the opposite of multiplication is division. And if we are multiplying and moving our decimal place to the right, when we divide, which way do you think we're going to move the decimal point? Well, if you said to the left, you're right, because we're just doing the opposite. So we can get from our original number to our final result just by moving the decimal place still. But instead of going to the right, we're going to move it to the left. So let's see if we can figure this one out together. I have 1,342.9, but I need to get to 1.3429. Here's what I'm going to do to make it easier on myself. If I have this pretend decimal here, I'm just going to put a little itty bitty dot. You can do the same. And now I'm going to be going 1, 2, 3 to get to my final answer. Well, I have 3 place values that I moved. So that means my answer is going to have 3 zeros in it. So now I took 1,342.9 and I divided that by 1,000 because I moved my decimal to the left this time. And I ended up with 1.3429. So we can multiply or divide using 10, 100, or 1,000 by moving the decimal either way. The main thing you need to remember is that if we're multiplying, move it to the right. If you're dividing, move it to the left. So let's look at a few more problems and see what we can do. Okay, so this last problem that we're going to work together kind of incorporates things from previous lessons, lessons from today. We're going to just chunk it all together, work through it, and it's going to be... So, for number 4, we're looking at 2.601. If we're looking at how we say that with place values, we have 2 tenths, hundredths, thousandths, 2 and 601 thousandths divided by 10 to the power of 2. So what I'm going to do is I'm going to simplify this 10 to the power of 2 first. I just want to solve it, get rid of it, make it easier, right? So if we stick with 2 and 601 thousandths, 10 to the power of 2 just means that we're taking the base and we're multiplying it by itself however many times it's in the exponent. So 10 times 10, because there's 2 tens, 10 times 10 is going to equal 100. So now hopefully that looks a little bit more familiar. So now we've got a 10, 100, or 1,000, and we know all we need to do is just move the decimal. Since we're dividing this time, that means we're moving our decimal point to the left. So 2.601 divided by 100, well, there's 2 zeros in 100, so that means we're going to move the decimal point 2 places to the left. So when I do that, if I take 2.601 and I move my decimal point to the left 2 times, well, it's going to end here, but I need to fill up this little gap that I just made. So I'm going to throw a 0 in there. And my final answer will end up being 0.02601. So that problem might look intimidating at first, but all we have to do is use the patterns that we found earlier and plug in what we know about exponents, and we're good to go. So those are some guided practice problems. Go ahead and take your quiz and email me your score. When you email me your score, all you need to do in the subject, just put 4 out of 5, 5 out of 5, 3 out of 5, 2 out of 5, 0 out of 5, and then that'll just make it easy for you and me. You can just put a bunch of gibberish in the subject, or not in the subject, but in the content. I don't care what it says. But in your title, in your subject, send it to me, put your score. See you tomorrow in class.